Good day everyone. Thank you for watching this video dedicated to the new Academia Learning Innovation Exhibition entitled Innovative Chemical Capstone Design Project. I'm Liu Pengyan from Malaysia Japan International Institute of Technology, MJIT UTM, as the course coordinator for the Chemical Process Design Project course. With me, I have the Chemical Process Engineering Program's Capstone Design Project Committee members, Professor Ezat Chan, Dr. Tan Dian Si, Dr. Nur Huda, and Dr. Karunisa, as well as our advisor, Dr. Fong Chan Chong from Medical Education and Research Development Unit, University of Malaya. This presentation covers introduction, common practices, the innovation and improvement made in this course, students' reflections, and achievements. Integrated Capstone Design Project is a compulsory element in all the engineering programs in Malaysia as required by the Engineering Accreditation Council. The Integrated Design Project is focusing on complex engineering problem solving in groups, which aim to evaluate the overall technical competencies and personal skills of a student. In chemical engineering programs, the Plant Design Project is a well-established format of Integrated Design Project, which connects the core courses studied in the first 3 years. The project demonstrates the connection between each subject for designing a complete chemical processing plant. In this project, the students are able to acknowledge the usefulness and importance of each of the subjects in the program. In the Bachelor of Chemical Process Engineering program in MJIT, the Chemical Process Design course is a prerequisite course for the students to enroll into the Chemical Plant Design project. The chemical process design is an important theory class for the students to be able to work on the design project in the final semester. The design project committee members are committed for continuous quality improvements for enhancing students' learning experience based on the feedback from benchmarking with other universities, external examiners, industrial advisory panels, industrial supervisors, lecturers, and graduates. The committee has benchmarked with several universities from time to time. It is found that most of the universities are offering the Capstone Design Project for 2 semesters, which the students have sufficient time for completing the project, while the theory classes are typically conducted 1 semester a year. However, chemical engineering programs in UTM are offering the Capstone Design Project for just 1 semester, which causes some negative impact to the students. In all the universities, academic supervisor is assigned to each of the group for monitoring the project progress and provide good input to the project. However, some of the lecturers are not taking the task seriously, which causes inadequate understanding on the requirement of the project. In addition, the coordinators are not constantly meeting the students for coordinations. Meanwhile, some institutions have project assessment that highly depending on academic supervisor, which is not able to demonstrate the reliable assessment to the students. Although the Integrated Design Project is very much industrial related, most of the universities are not providing sufficient support for the students to acknowledge the gap between academic and industrial requirements. Only some academic advisors put personal effort to invite industrial friends to provide some feedback to their own team. Therefore, our committee came up with 3 initiatives. First, the integration of teaching, learning and assessment through cooperative and project-based learning throughout the Chemical Process Design course and Chemical Plant Design Project course. Secondly, holistic assessment is designed in the course for assessing multiple intended learning outcomes from technical to soft skill through multi-dimensional approach from various parties. Lastly, comprehensive industrial exposure are provided to the students for them to understand the expectation from the future employers, which bridges the gap between the higher learning institutions and working environment. The first initiative integrates teaching, learning and assessment through cooperative and project-based learning. The committee decided to integrate the theory course with the Capstone Design Project course. Commonly, the students are required to learn the design theory before enrolling into the project course. The students are required to learn the heavy design concept on paper, and the assessment are done in traditional examinations, which chop the knowledge into pieces for teaching, learning and assessment. Although some lecturers are requesting the students to do mini project for the theory course, however, proper guidance are not able to be provided due to the course assessment is still focusing on the examination. As a result, horizontal integration is used in our program, which the revision supports the students' learning on theory and practical aspects. The course instructor provides necessary support to the students during the lecture according to the project progress. With the knowledge gap found by the students during the project work, the theory class are able to scaffold the students appropriately while maintaining the students' interest for effective teaching and learning. Formal cooperative learning activities are used in the classroom, which lectures are filled with activities according to the project teams. For example, group brainstorming activities is done for reminding the students on the previous learned subjects and connecting them for process design. Modified jigsaw activity Avengers Training Centers is introduced to the students for learning chemical process design heuristics, which promotes individual accountability, positive interdependence, group processing, face-to-face interactions, and interpersonal communication skills. On the other hand, the instructor also conducted some team building activities for creating awareness on the important elements for ensuring team dynamics, such as communication among the group members and listening to others' opinions. This is also essential for ensuring the students fulfilling the soft skill assessment. For the project-based learning course, the assessment is essential, which measures the ability of the students for each intended learning outcome. The validity and reliability of the assessments are important for ensuring a fair grade is given to the students to represent their mastery of the outcomes. The assessment method for each outcome is carefully designed for ensuring the reliability. The multi-objective and multi-dimensional assessment in this work promotes the development of holistic graduates. Self and peer assessment is used for assessing the students' teamworking skill, which also represent the students' contribution in the team deliverables. The self and peer assessment result is contributing to the auto-rating factor for all the team assessments. Meanwhile, academic supervisor is evaluating a small portion of the assessment on ethics, teamworking, and project management. Since industrial supervisor is meeting the design teams regularly, they are also given a portion of marks for teamworking assessment. For continuous technical and also communication skill assessment, lecturers are assigned to evaluate their project reports and progress presentations. 2 lecturers are assigned to go through the same chapter for all the groups, which allow the lecturer to compare the level of achievement and provide relatively reliable feedback to the students. In order to provide a reliable summative assessment during the final presentation, the committee invited external lecturer and industrial assessor, which a team is assessed by 2 academicians from other universities and 1 from industry. The assessment focused on technical and presentation skills. The external lecturers are playing an important role to give independent constructive feedback to the teams from academic perspective, while the industrial panel will be looking from the perspective of future employers. In this slide, we can also see during the 3rd CPE Annual Chemical Engineering Design Exhibition and Seminar in 2019, which we have 3 industrialists and 12 academicians from other universities were invited to evaluate the students' presentations. The last agenda is to formalize and increase the industrial exposure to the students. Industrial supervisors are appointed for the regular commitment in the students' project. The supervisors are expected to provide continuous feedback according to the project progress, which is able to check the technical feasibility of the proposed process design and retain the students' motivation in the course. With these sessions, the students are able to observe the key elements that emphasize in the actual industrial requirements. In addition, the industrial assessors during the final presentation is important too, which demonstrate the presentation situation in real life. In the previous cohorts, the committee has invited assessors from various companies such as Petronas Research, Petronas Group Technical Solutions, Afnan Engineering, and Enquest Petroleum Productions. The assessors visit the exhibition booth prepared by the design team, which the students are able to feel the stress from the conversation with the industrial experts. This will be able to help the students to know the expectation from the future employers. According to the student reflections, the 2-semester integrated course managed to change students' problem-solving, mindset, and attitude. They are generally able to appreciate their improvement in problem-solving skills, presentation skills, and self-confidence. With the self-confidence gained, the students are able to justify their idea and decision with solid justifications. Teaching and learning activities for supporting the project-based learning are recognized to be able to help the students in their Capstone design project. Students are able to learn in a fun and enjoyable situation with their teammates, which also promote the team harmoniness and further helps to improve the team dynamics. The students believe that the regular self and peer assessment is a good method for improving the team dynamic, which improves the interpersonal skill for each of the students. By performing the self and peer assessments, students are able to recognize their good and shortcomings when dealing with their teammates. The comments from the peer assessment promote personal reflections through reading the comments from their teammates. The regular industrial supervision sessions help the students in bridging the gap between academic and industrial requirements. The students are able to solve some of their doubts in the supervision session, and some of the students are able to understand the responsibility of an engineer in industry. The validity of the self and peer assessment have been studied by the team and published in the International Journal of Engineering Education, which proven that the self and peer assessments are able to converge with sufficient training provided to the students. On the other hand, the project was selected for participating in an international competition by Palm Oil Special Interest Group in the Institution of Chemical Engineers, which our team won the Best Final Year Design Award 2019. Based on the author book by the chairperson, the judge was amazed with the report produced by the team, which the students has provided in-depth analysis and consideration on social and environmental impacts of the design in this academic practice. That's all about our innovative chemical capstone design project, which improvements have been done for the teaching, learning and assessment. We believe that a well-structured capstone design project would be able to help our students in improving their technical skill and, more importantly, their soft skill and confidence level. This is a very essential process for preparing our students in facing the real world. Thank you.